this is problem 77 of Neetcode 150. Implement a trie. So a trie stands for a prefix tree. Honestly, this problem is going to be quite challenging if you have no knowledge about trie. If you do have knowledge, it is actually probably the simplest problem you can think of if you have to deal with trie. So let's go ahead and read the problem. A prefix tree, also known as a trie, is a tree data structure used to efficiently store and retrieve keys in a set of strings. And then they say that this is used in autocomplete and spell checker system. Okay, good, but we want to have the problem. So we're gonna have to implement prefix tree. So we're gonna initialize this object. So we're dealing with OP here. We're gonna have to create insert, and insert is a function void, so it doesn't have to return anything. All right, so we're gonna have to insert a string into the prefix tree, and we're also gonna have to write search, and we're gonna have to return through if that word is that we're looking for is already in the tree, and false if it is not. And we're gonna also have start with. So if there's any word, for example, there's apple in the tree, and we want to say if there's a word that starts with app, well, yes, we're gonna have to return true. I think that the core of this problem is just to understand what a trie is. Okay, so let's say I have the word apple, and I will start here at the top of my tree, and I will add a, then I will add P, then another P, then an L, then an E, and we have to know what is the end. So we're gonna have to add a dot here. So let's add this here, okay? Now, what if I come up with the word APP again? So what do? Do we add another branch starting with A and we go again with P? Well, that's not the best way to use the resource we already have, right? So we're gonna just go here and we're gonna go see A, P, and P. And at P, we are gonna add a point here. So we're gonna say that this word is exists basically within this greater this greater word called apple. Okay, and now if we have, for example, ban, we're gonna have to add another branch here called B, then A, and then N with a dot. And now if we want to have banner, right, we're gonna have to add another branch here for N, for E, for R, and then we add a dot. So this is what a trie looks like visually, but now you might ask, and I also asked myself this question at first, what does it look like in coding, right? Well, let's take a look at this. Okay, so let's basically a trie is a nested is many nested dictionaries. So we're originally gonna have a, right? So we're gonna have a, and the value of a is also gonna be a dictionary, and within this dictionary we're gonna have p. So p is gonna be another key, and it's gonna be key, right? And within p we're gonna have another p. So you can see how nested the thing is. And within this p, right, we have another p. But now we have a couple values. First is actually a dot. So we're going to have to say something like this, dot, dot. All right. But also p is also going to be, it's going to have the value L, right? So we're going to keep going. We're going to say L, and basically our L itself is going to be inside is going to have another dictionary. So all right, so the P is also pointing to L. So L is going to be here. So within the dictionary, that is the value of P. And L is going to have another dictionary, which is E as the key. And the value of E is going to be dictionary, where we have a point. Okay. So yeah, it's a pretty complex structure, but this is the actual formal way to visualize a trie, because what we have to the right is just a visual representation that helps us understand how it works. But actually, in terms of code, a trie is a nested, it's many nested dictionaries, one within the other. So with that being said, let's actually code this. So first we are going to create our constructor function, and we are going to set trie. So we're going to say self the trie, and we have to start with a dictionary like this. So that's the init function. Now how do we insert a word? So basically, if a word is well, if the first letter of a word is already in the trie somewhere, we don't want to recreate it. So what we're gonna say is that well, we're gonna set the trie to D. Okay, so it simplifies the way we call it. So we're gonna say just self the trie. All right. So now we can just use D without always rewriting self the trie every time. And now we're gonna say for C in word. So for each character in a word, what you want to check is basically if the C is not in the trie. So we're gonna say if C not in D. What if it's not in D? Well, it means that we have to create another dictionary from pretty much from scratch, because each branch of the trie is actually a dictionary, as we saw with the example apple. So we're gonna say that D, and we're gonna pass the key of that character. It's gonna be equal to a new dictionary. And every time we want to go one layer deeper inside the nested dictionaries, so we can actually, right, because for each character, it's like if the word that we're given is apple, we want to first see if A, so the first character C here is going to be A. So if A in word, if A in D, so initially D is pointing at the surface layer of the dictionary. So yes, it is there. So we have like a really nested dictionary that starts with A. And now we want to see if P is within this dictionary. So we have to go one layer deeper inside our tree every round. So we are going to do this by saying D is equal to that D at the character C. Okay. So we will do that every time, and we want to insert, right? So what is left for us to do at the end of the insertion? So after we created the new word, we want to add this dot, and we are going to add this dot by saying we're going to call the dictionary, and we are going to explicitly add the value dot, and we're going to set the value dot to a dot. All right, so let's just do it this way. So now we create well, basically we're going to go for every single characters in the word. If that character is not at the surface layer that we are at in the dictionary, we are going to create a new dictionary, and we are going to add basically and here I made a mistake. We are going to basically move our pointer D to that nested layer, and at the end we are gonna add a point here. So we specify that this word is over. And now we're gonna complete the search function. So we're gonna set the trie to a variable again. So we're gonna say self the trie. Okay. And now basically in the search function, we have to return a boolean. So we are once again gonna go see if each character of the word. So we're gonna say for C in word. So cool. What do we want to do for each characters? Well, if the character is not in the dictionary, we don't want to create a new dictionary. We want to return false. So we're gonna say if C not in D, right? This is not where we want to add another dictionary. We just want to return false because we don't have this word. All right. And we're going to move our pointer again. So we're going to say D is equal to D at C, because every time we have to go one, like if we don't return false here, it means that we add the right letter. So you want to go stick one layer deeper in our nested structure to see if the next character is going to be the same. So if we never return true, well, if we never return false, it might means that we have a word, or it might means also that the word that we're looking for is a substring within another string. For example, if we have apple, but we are searching for app, well, we should technically return false, okay? But if in this current code, we will technically not return false because there won't be any place where the character won't be in the dictionary. So what we have to ensure, we have to ensure that the words end by a dot. So we're gonna say if dot in the. So if this is not the case, it's gonna return false. It means that the next character is another letter. And if it's a letter, it means that the word is longer and we are not actually, we don't have the same word that we're looking for. We have like a longer words that contains the one that we're searching at. So if it really has to end with a dot. Okay, in the search with, it's pretty similar. We're gonna set our D, so self.try again. And we're gonna go for every character. So we're gonna say for CN, and now we are not given, we're not giving word, we are given prefix. So for C and prefix, once again, the logic is the same. We want to check if the C is in the D, right? But if it is not, so if C not in D, we are going to return false because we don't have this prefix in our dictionaries. And at the end, if we don't return false, it means that we have the right word. So we are going to be willing to investigate further in this nested structure of dictionaries. Okay, and at the end, if we never return false, it means that we actually have this prefix. So we don't need to return if true if there's a dot. We can simply return true as it is. Okay, so this is a try. You could use a function in Python called try node. I think potentially be easier, but well, it will be easier to conceptualize. I think at the end it will be more code actually. But understanding that fundamentally a try is a structure of nested dictionaries is really the best way for you to really get to know what it is and how to actually create a new dictionary when you're inserting a words, not just recreating the entire words. So, and then also moving your pointer and adding a dot at the end or whatever you want to add to specify that this is the end of a word. This is super powerful. Okay, so I hope you learned from this video and I hope to see you in the next one.